Hello and welcome to session 197 in the AISafety.com reading group. Tonight we will continue with the podcast Ben Garfinkel on scrutinizing classical AI risk arguments. Ben Garfinkel is still a research fellow, and Howie Lemble, Robert Whipplin, and Kira Heron are the three people on the 80,000 Hours podcast team who has been working with this podcast. This was published almost 2 months ago, but recorded about a year ago. And today we're taking the second half, starting at the 1 hour and 43 minutes mark, the section called Instrumental Convergence. Instrumental convergence is criticized in the following way. It would be possible to make a methodology for predicting technology by looking at all the possible combination of features that it might have and see if most of the ways to make this technology involve a particular property. Probably when we make this technology, we will make one that has this property. And this, I feel, is not really how the instrumental convergence is argued in most cases in the classical presentation. It's not that most ways have this particular property. It's that either we are in a very, very degenerate case, or we are in something that is explicitly positively aligned, or we will have these instrumental convergent goals. And so the way Ben Garfinkel argues for most of the ways is by analogy of a plane with either open or closed windows. And he further argues that this is the methodology that's used to argue for instrumental convergence in the classical AI risk arguments. So this way of looking at kinds of technologies can probably be formalized with a bit string with like there are this number of descriptions, and the ones that are if most of these, you can just count them, have this property, then that's what would have it. But that is emphatically not how it is commonly done in the classic AI risk arguments. The first on instrumental convergence is by Stephen Omohundro, the basic AI drives, where Stephen Omohundro uses a definition and an argument structure that is much closer to the one I have up here, which does not have the word most, but saying that either we design it very, very particularly, or it will have the instrumental convergence of goals. It's also not how it's done in Bostrom Book's Superintelligence, where instead of just looking at all possible programs, we're looking at not just the space of all possible programs, but the space of all programs that have been filtered by humans that are searching for an AI that has some kind of goal that the humans are interested in, and where the AI, it might not have that goal, but it will look like it has this goal. And I think probably this is what Ben Garfinkel is arguing that you should do. Instead of just looking at all these possible programs, you should look at the ones that look like they are promising, and this is what Bostrom does, and it doesn't really solve the problem. Most of the ones that look good still are not perfectly aligned and subject to basic AI drives. Also, there are some problems in the transcripts around here. There were some parts that I couldn't quite pass. These arguments for this is the third major argument for problems in the original AI risk arguments, and these arguments are entangled in the following way. AI researchers are likely to steer towards some designs that are safer, and that's because we will have much more smooth and not in particular not an intelligence explosion, but a more smooth scenario. So that means we will notice the problems while they're small, and the alignment research will be automatically improved along the way because it's a requirement for capability progress. And in this way, the arguments for or against AI risk mutually reinforce each other. In particular, the takeoff speed acts as some kind of multiplier or intensifier. And this means that if you have some model of how the future is going to be, and then you just tweak these small parameters, even just a tiny bit, then if you are 10% more optimistic on a rather small number of cases, you can end up with a dramatically more optimistic or pessimistic, for that sake, conclusion. I think if you're in a situation where the arguments are entangled in this way, that should mitigate against strong confidence either for or against, because if you can suddenly get into a Ben Garfinkel doesn't need to be very wrong on many of his assumptions. As long as he's wrong on several of them, then they will mutually reinforce, and then suddenly we could have a serious AI risk. And also, of course, the same for people who are certain that there is doom. Because if we have a bit more time, and if alignment progress is a bit more required, then a lot of things will look a lot lighter. Then there's the question of neural networks. Howie Lemble asks that if the space of possible AI designs is very dense with bad scenarios, so even if you change a tiny bit and don't get alignment 100% perfect, then you might end up in an awful scenario. Ben Garfinkel answers in the following way by looking at neural networks, where if we make some small perturbation to the neural network, change one weight or something like that, then generally the behavior is mostly the same. And I believe that is true. Even Ben Garfinkel is not completely certain about this, but I believe it's true for capabilities. But we don't really care much about capabilities when we talk about the instrumental convergence thesis. We talk about goals. And indeed, for goals, small perturbations can be very, very problematic. There is the complexity of values thesis, which holds that, of course, small perturbations can destroy everything of value. There are also the fact that, for instance, something like a utility maximizer and a disutility maximizer are extremely close in bit space. You only basically need to flip one bit. And of course, the actual behavior is dramatically different. One of the things in particular that will cause substantial problems, or could cause substantial problems, is that very close to an AI goal set that we approve of is an AI goal set that humans will actually fight against because we don't approve of it. And that means that the capabilities and the actual scenario of what will happen with an AI, it depends intimately on whether we will cooperate with it or if we will fight it. And that means that even quite small changes could have dramatic threshold effects. Ben Garfinkel also argues that changes in distribution, which is another thing that could happen, will give incompetent behavior rather than dangerous. This is something that could happen. The classic AI risk arguments are particularly interested in the changes in distribution, which are relevant to whether the AI perceives that it will be able to make obtain and decisive strategic advantage. Also, distributional shifts, like for instance, what precisely corresponds to a human or something like that, could invalidate all alignment work, and that's also something that we need to look out for. Then there is quite a bit about MESA optimization. There's a description of this, and some of it is correct, and most of it is probably not quite as correct. And Ben Garfinkel states many times that he's actually not really sure about this, and this is something that is, if not really new, then at least moderately new. Also because Ben Garfinkel had this podcast a year ago, so back then it might have been newer. But I think there are very serious problems with Ben Garfinkel's description of MESA optimizers. I think the key point is that MESA optimizers are about learned models that are themselves optimizers. And this is a classical image, and there is nothing in the description Ben has that really relies on this in any way. It's usually just the standard problem that's sometimes called outer alignment here. Ben doesn't say anything really that leads one to that forces you to conclude that he actually understands meta optimization. It should be said, when they're talking about the evolution human analogy, they do get closer, but there is nothing really about meta optimization in what Ben Garfinkel is saying. Ben Garfinkel also talks some about the relationship between meta optimization and distributional shifts and why we care about those. And I think also that description, if I should describe why we care about that, that's because if we have a meta optimizer that is deployed in training, then this will actively be looking for a distributional shift that will show that it's no longer training, but now it's actually capable of performing a treacherous turn. In this case, these small perturbations that we talked about could be really, really interesting. Because here we have an intelligence that is adversarially looking for these small distributional shifts. And in this case, even very small things can be very problematic. But this might not really be relevant to what Ben Garfinkel is saying. It's somewhat unclear from the transcript, this part, unfortunately. On the other hand, one thing we could say is that meta optimization, obviously, is not part of the classic AI risk arguments because it's a lot newer. So why is there so much talk about this? Well, I believe that if Ben Garfinkel had written a formal article, then probably there would not be so much talk about meta optimization. But if the question posed by Howie Lemble, what are the best counter arguments to your own arguments? I think it's a really hard question, and this is the context where Ben Garfinkel talks about meta optimization. And I'm not really sure I like this kind of questions. It's really hard to skip over, even if you don't really have anything good to say because you feel you've already answered the main points. Then there is some talk about what Nick Bostrom calls perverse instantiation, even though that's not really the word that Ben Garfinkel has used. Ben Garfinkel states that there are 10 pages in the book Superintelligence about how these benign seeming objectives actually are really problematic. So I looked in Superintelligence. I have around 1 page about this, 2 if you're generous. But Ben Garfinkel argues that this kind of thought experiment doesn't really tell us much about what the future will actually look like. And this is something that is acknowledged explicitly by Bostrom. These are illustrations of why naive alignment methods fail and not meant as any kind of prediction. The argument by Ben Garfinkel here is that if we will probably, once we have very powerful AI, it will probably be based on machine learning and not on feeding in English language sentences. If we wanted to have powerful AI based on English language sentences, it must have common sense understanding. And if we have that, then this common sense understanding will also be applied to the goals. So this calls back to the brain in the box confusion that we saw in the previous session. Because in the classic AI risk arguments, then we're talking about a C AI that can improve itself, rewrite its own source code, but it does not have any kind of common sense. And then if it's given a goal, then the literal interpretation of these goals will be locked in during this process and will not be changed. Ben Garfinkel has an analogy from a movie called Explorers, which is about people who receive some requests and then horribly misinterpret them. And if an AI is trained on that, then what will happen? I tried to figure out what this is a reference to, The closest I could get is Dora the Explorer, but from the Wikipedia article, I'm not really sure whether that's that. So I would be interested if anyone knows about an Explorer movie where anything like that happens. Then there's a part about the treacherous turn. And there's a description about the treacherous turn. Again, it's relying on meta optimization, which is explicitly not a thing that the original description does. It's the description of the treacherous turn is also strictly assuming a smooth scenario. And in the smooth scenario, we would expect to see a number of failed attempts of deception, or some deception that exists but isn't really problematic, or at least not catastrophic. And I'm not quite as optimistic as Ben Garfinkel on how we will see this and how we expect to see this. Because if we have, just a neural network, then figuring out if it's really deceptive or not, it's really hard to peer into these kind of learned models to figure out things that are on the level of whether it's deceptive or not. And in particular, if an AI attempts a takeover without deception, then it's very likely, of course, that it's dramatically more likely we'll notice it in this case. And unfortunately, the answer to that is yes, it is very, very likely that if the AI notices it can take over the world and then takes over the world without at any point deceiving anyone, then of course we'll notice it, but it will also have taken over the world. So it's not really a lot of help that we will see it. This treacherous turn, how dangerous that is, relies on how smooth the world is. And indeed, if as the transitions become faster, treacherous turns become more dangerous. Ben Garfinkel have the following statement here that it's not really related to the treacherous turn, but I have a lot of trouble understanding how you get to the point where an individual system is powerful enough to destroy the world. I think this general framing is really problematic, because the way I normally when I try to summarize the argument given in superintelligence, I divide it into 6 parts, like A implies B, etc. And if you zoom out all the way, like from A to G, then it does seem like a big leap to going from you have an AI and suddenly it has taken over the world. That does seem unlikely, but the point of scrutinizing classic arguments is that you have to go into all these small sub-implications and see whether those are actually true or likely, and then the intuitive feeling that the entire thing seems unlikely, it might still be useful, but scrutinizing the arguments themselves, I believe, is more important, and that's certainly what we're supposed to be doing here. So how many systems will be treacherous? Again, if we are in the smooth scenario, so there is no intelligence explosion. If we imagine that there are millions of machine learning systems deployed all over the world, many kinds of capabilities and motivations, etc., then it would be quite surprising if a lot of those were treacherous and we didn't notice that at all. And this is of course true, but the classic AI risk arguments don't really talk about the smooth world. They talk about the world where things are much more lumpy. And in this case, of course, we would notice the first treacherous turn, but then it would be too late. Ben Garfinkel in the smooth world gives an example, specification gaming. He also we talked about this in the previous session, and it says this is an example of lying and not getting away with it. So as I see it, this argument doesn't really work, because specification problem, if it was a problem, we would notice it, and we currently notice it, so it's not a problem. So I feel this is the way with specification gaming. We notice that there is specification gaming. So AIs, obviously, if you believe that specification gaming is an example of lying, then AIs obviously lie, right? And then there is obviously a problem. But as I said in the previous session, I don't believe that specification gaming is actually lying. I believe that you, in order to make what is actually a lie, you need to have a model of what does the person that you are talking to, communicating with, what does he believe. And if you don't have this kind of theory of mind, then you're not actually lying. Howie Lemble again tries to put the discussion back on track. What if the AI doesn't start lying until it has a high confidence it can take over? Benker-Finkel answers, well, if the AI is 90% certain, that then if there are millions of systems, then sometimes we will catch them. And that's of course true, but it's not just lying, it's lying, it has a high confidence that it can take over. And of course, if an AI, in particular superintelligence, has a high confidence that it can take over, then there's a very great risk that it will indeed take over. And then it will not take millions of AI systems before we have a takeover. It might only take one. I think actually there is an argument here. You could argue that if the first AI that is a general AI, or at least have theory of mind, so it's capable of thinking about whether it should do a treacherous turn, and it believes it has an extremely low probability of taking over the world, then I think if it's a paperclip maximizer, it would try to do that, even though it's very likely to get caught. And I think something like that might be possible for a honey pot or something like that, in order to catch these AIs. I think there might be something there. So about lying. Children are slightly cognitively impaired agents. I think that's a great way to put it. And children lie a lot, and they often get caught. And this seems to imply that you need to learn how to lie, and you can't get good at lying until you've actually had experienced lying. And so the obvious objection to this line of thinking is that we don't really know at all. We don't know if a superintelligence that has never tried to lie will actually be good at it. I think I would expect it to be very good at lying, even though it has never done that before. There is some fictional evidence you could put forward, but I think the main point is we just have absolutely no clue. On the other hand, we could say, how hard is it to lie? Because at time t, we imagine a robot saying, "I am an A maximizer." You could say that is a human utility maximizer, and then after the AI has reported that to the human, it thinks actually it's only maximizing smiling faces or something like that. So how can it lie? How can it make the human believe that it is still a maximizer, a human utility maximizer? Well, it's really, really simple, because at timestamp t plus 1, it just repeats what it says at time t. So this is actually a really, really easy way to lie. If you're just supposed to first say one thing genuinely, and then later repeat the same thing as a lie. Also, we imagine that once the AI is at the level where it can improve itself, it probably cannot conceive about lying, but at the superintelligence level, then it almost certainly can. And the question is, will anyone even think to ask it in between these 2 points? There is another kind of argument here that comes up, where Benker-Finkel points out that the treacherous turn doesn't explain why the AI would either have power or why it would want power. And this is, of course, a different part of the argument. The argument is commonly structured in several parts, and for each path, it is true that it doesn't explain the others. So in that way, you can put a question mark on each subpart. But I believe this is a logical error. Each subpart of the argument only explains what it's supposed to do, and the fact that it doesn't explain the other parts is irrelevant. Hold on, let me just see if I can get this Windows taskbar away. Yeah, good, great. Okay, so we don't really have very tight and perfect mathematical arguments for AI safety. And if we want to put a lot of resources into managing AI risk, then we would really like to have very good arguments for it, both about whether there is a risk and more concretely what will look like, and of course also what can be done to mitigate it. And that's just for the classic AI risk arguments. For some of the newer like Ray Dyer's argumentations, for instance, we haven't anything that's anywhere near as formal. And to this, I can only say that I agree, and I believe that this is something that would be really nice to have, and something that I care a lot about. And getting these arguments shaped up is, to use the classical EA methodology, important and neglected, but unfortunately I believe that it is not tractable. I quite simply believe that the book Superintelligence presents the arguments roughly as well as can be, and is just a general fact about our epistemic state that predicting the future is really hard. So, assuming that the superintelligence does indeed present the argument as well as possible, then it obviously doesn't convince anyone, and I would then say that probably there are no arguments that can resolve the debate as it is right now. Unfortunately, we just don't know. So I think the best we can do is to examine counter-arguments like I'm doing here with Ben Garfinkel, because I don't think we are going to ever be able to strongly resolve this far in advance. Ben Garfinkel has, well, the arguments that Ben Garfinkel have presented have influenced his advice to people from effective altruism. He believes that if you are a machine learning researcher and you're really interested in long-term perspective, then you should probably work on alignment. If you're working in governance and have a strong interest in computer science and machine learning, then it's a really good idea to work on AI governance. If you have many options and alignment in AI governance is not really the best ones, but there are others that are better, then Ben Garfinkel is uncomfortable advising them to work in AI safety. So this is really weak advice, and I think most people would agree with this, because it's equivalent to working on what's your best fit, but it's some really strong words, right? If you are a machine learning researcher and really interested in the long-term perspective, right? There are an excluded middle here. For instance, people who are closer to AI fields than other EA fields, but not extremely so, like they are established researchers. I think in this case we probably have like three arguments. We have the rigorous argument as presented in the book Superintelligence. Then we have some other AI safety arguments that haven't really been formally written down. And then we have the counter arguments, which are also informal. And so Ben Garfinkel says that the informal arguments for AI safety, he's not confident, changing his advice based on that. But his own informal argument, he does want to give advice based on that. I think it's minimal hypocrisy in the way that it's very human to overvalue your own arguments. That if you believe that informal arguments shouldn't have much weight, then when they're your own informal arguments, then you kind of tend to give them more weight. But this is not an obvious way to do, because there is indeed a reasonably well-established social phenomenon called the information cascade, where the classical example is there is a jar here, and then people take turns on drawing a ball, and they have to state whether they believe the jar is mostly red or mostly blue, and you can see what the people before you have chosen, and then very often it makes sense if all the others say it's red and you pull out a blue one, then you might want to say, actually I believe they are all red, or mostly red, of course not all red, but mostly red, because you have the evidence from all the others. And this could be something that is happening with AI safety, in that people believe that everybody else have looked deep into the arguments, and so they defer to them. Or maybe the criticism have been answered by a Google Doc or somewhere. I believe that this is rather unlikely, in that people are not saying anything like that. People are instead strongly pointing towards the book Superintelligence as the canonical representation. So since people are not hiding Google Docs or anything, but explicitly pointing towards the book Superintelligence and saying this is what I'm basing it on, then you can actually read it for yourself, and there is no particular private information. Then I have I think I'll skip through this, but point out that this is something that you could actually investigate empirically by asking people why they believe what they believe. Now there are a number of concrete counter arguments that have been made against the book Superintelligence, including Robin Hanson, who is mostly arguing using the outside view, Katja Grace, who is also mostly arguing about the outside view, Brian Tomasic, who is using the inside view, and Paul Christiano, who is both using the inside and the outside view. I have in this reading group made similar presentations where I've engaged with all of these, and a number of them do have good points, but some of the major points unfortunately do have major flaws. And I think it's a sad thing that when these 4 people and a number of other people make criticism, then there is no formal structure for capturing this. And when I make any kind of reply to this, again, there's no formal structure, so it kind of just ends up in nothing. And I think that's really sad, and it would be great if we had some kind of formal structure. And further, these kind of arguments, when they are in these 4 people have made reasonably public and reasonably polished also arguments, but a lot of the arguments for and against are in private Google Docs, is asserted by Ben Garfinkel. I actually don't know whether that is true, but it needs to really move to something more formal, because this really helps arguments. This makes arguments a lot stronger, and I agree with this. And I think the big problem for this, when I've tried to do this, for instance, I tried to do an adversarial collaboration on Slate Star Codex on the intelligence explosion. And the problem is that when one side has been written down very exhaustively, then the playing field is extremely unlevel, because the counter arguments needs to reply to those, and there's a lot of work that needs to be done by one side and not the other. And that makes it really hard to get traction, at least in my experience. So I don't really know how to make a formal structure for this kind of feedback. Ben Garfinkel has a quite nice analogy with Zeno's paradox, the paradox with Achilles traveling first half the distance, and then 1/4 of the distance, 1/8 of the distance to some point, and never actually reaching it. There wasn't really a clear explanation of what. It's obviously intuitively very wrong, right? You will obviously get to this point at some time, but what is the thing that is wrong with Zeno's paradox? This required quite a bit of mathematics. Ben Garfinkel says that it wasn't until 1900, I believe, that in 1821, Cauchy published Cours d'analyse, which I believe introduced the epsilon delta definition that I would use to explain Zeno's paradox right now. But I think the point stands, right? This is something that was explained as a paradox for 2,000 years, where people really couldn't figure out what was the exact problem with this. And it's really hard to articulate what are the issues with arguments that use fuzzy concepts, like movement and distance, for instance, before you had the mathematics for it. And I think this is why we should probably expect that something like the book Superintelligence will have some mostly poor criticism. But even though a lot of the criticism is poor, the underlying intuitions that people have that it is wrong is something that needs to be respected. And I believe this is true. And you could actually say that's something like the offense-defense balance here, in that writing a book about a bad prediction might indeed be easier than doing the work at criticizing it and pointing out precisely where it's wrong. The final point is on AI safety as a field. How much money does this deserve? Ben Garfinkel have a cute example of the film Boss Baby, which has its production and marketing cost substantially more than has ever been spent on AI safety. When he thinks about how much money should be spent, then he compares it to things like pandemic preparedness, nuclear war, climate change, this kind of thing. And he believes that the AI safety level is way too low, and it's hard to argue against a 5-time increase, 5 times more than the Boss Baby. So I looked up the budget, $125 million. So 5 times that would be 625 million. So I tried to calculate if this is reasonable, both with how many people would that fund for how many years, and as a percentage of both AI and the world GDP. And I kind of got stuck in this. I'm not an expert in this. So I couldn't figure out whether that was reasonable or how you could argue for 5 and not 20 or 25 or whatever. So I tried to look for a formal calculation. I couldn't find that either. I did look into the Oxford Prioritization Project, which does something like this. I think that's probably a requirement to have something like their guesstimate model in order to say whether this is actually true and whether this corresponds to the other probabilities that Ben Garfinkel have given for AI risk. That is all for today. Thank you and see you